All right, so continuing our discussion on patterns and linear functions, we have some additional terms that we would like to discuss here. First thing is when we talk about the word function. A function is a relationship wherein you have an input value and it is paired to exactly one output value. Okay, one input pairs with one output. That's a function. If you have an input and it's paired to different or multiple outputs, that is not a function anymore. Okay. A linear function, on the other hand, is an example of a function wherein the graph is not a vertical line. Okay, or it is not even a part of a vertical line. So a linear function could be like slanted. It could be horizontal. Definitely not vertical. Okay, so let's have this example here. So the table below, okay, shows the relationship between the number of photos. So the number of photos is represented by our variable x. Again, x is our independent variable. The memory, on the other hand, okay, the memory of your memory chip, okay, will depend on how many photos you have used. Remember, okay, so our memory in megabytes is our dependent variable y. Okay, so is this relationship a linear function, and how can we describe the relationship using words, equation, and a graph? Okay, so for us to see if we have a linear function, definitely if we put it in a graph, and you will see that the points are aligned perfectly and makes a straight line, then you know it's a linear function. Now, if you are given a table, okay, one technique that you will be using to identify if your function is linear or not is you have to check if the pattern is consistent between your input value, okay, and also what pattern is existing with your output values. Okay, let's take a look with our input first. From 0 to the next value, so what did we do here? We actually added 1, all right? From 1 going to 2, how much change happen? Again, you added by 1. And you will see that's a +1, okay? And then you can see that consistently we always add 1 on our input. Now, is that good enough reason for us to know that this is a linear function? Not yet, okay? Remember, there should be a consistent pattern as well with our output values. So let me switch colors here. Now let's take a look. From 512, it became 509. What changed? Happened here. From 512 to 509, we actually subtracted by 3. Yeah? Okay? 509 to 506, again, another -3. 506 to 503, still a -3. So because there is a consistent, okay, increase on your x values, on your independent variable, there's also a consistent decrease on your memory, on your y value here, then because of this pattern that we observe, then we know that this is going to be a linear function. Oh, by the way, if you see me write fxn, that is just the same as function. Sometimes it's my shortcut on how to write the word, okay? So that's that. Now, how can we show or how can we prove that this data set is indeed a linear function if we're going to use it in graph? So we have this graph here. Now, as you can see, we don't start with 0 anymore. As you can see in this graph, we have that it's like a cut there, meaning we did a shortcut. We're just skipping to the 500s value for our y, okay? So if we plug in our points, okay, when you have 0, when you have not used any photos yet, what is the memory, the size of the memory? It's gonna be 512. You did not use anything, okay? Next, if you have used only one photo, it drops to 509, so it's gonna be over here. I'm sorry, I don't know why that one keeps on showing up. I'm trying my best to get it done there. Okay, just imagine it's a solid dot. Okay, if you use 2 pictures, it's at 506. It shows up again. Okay, and then if you have 3 pictures, it's gonna be at 503, so it's gonna be over here. So what can you predict to be the number of what will be the memory size if you have 4 pictures? So if you subtract another 3, then you will be at 500 megabytes. Okay, so you would see that this is going to be a straight line following here. So I'll try my best to draw the line. Okay, and you have to pardon me. Oops, going back, sorry. And you have to pardon me if it doesn't show a straight line. I don't know why it keeps on switching back to that. I'll try, like I said, I'll try my best to keep it a straight line. Whoops, it didn't touch any of the points, my bad. So you will see that it's going to be a line shown for those points. Let me just remove that. I think it's just going to be crazy to look at that, sorry. So that's a 506, 503. Okay, there we go. First world. Okay, there we go. So how will our equation look like? Okay, oops, my bad, that's my fault. Okay, the equation, okay, if you will take a look, the y value, the memory, the size of the memory chip will be depending on how many photos were taken. Okay, now you will see that for every photo that was taken, it will deduct 3 megabytes from the memory itself. And so our original size, which is 512, will be subtracted by 3 times the number of photos. Okay, and what is the number of photos? That's our x. So our equation will simply be 512 minus 3x, and basically in words that's just the same. 512 subtracted by 3 times the number of photos. Okay, so why don't you try this next example here on your own? Try to see, is this a linear function? So check the patterns, is it consistent? And then how will you write the equation? How can you show the graph? And how can you write it in words? Go ahead. All right, so if you're going to check the patterns of our input and output, so you can see it's consistently adding 1 to our input. Our output is consistently adding 2 every time. So that satisfies our linear function checklist. Okay, so if we are going to graph it, so I tried my best to do a handwritten graph here. So you would see that those points will definitely follow a straight line. It's a steady increase by 2. And so our equation, you will notice that every time your y is simply adding 8 to twice whatever the input is. And so our equation is 8 plus 2x, or you can have it as 2x plus 8. All right? So to summarize our discussion, the value of one variable may be uniquely determined by the value of another variable. So that's the relationship between our independent and dependent variable. And relationships may be represented using tables, using words, equations, using sets of ordered pairs, and of course, with the use of graphs. Okay.